Okay guys, we are going to begin Unit 7. We'll start with 7-1, and the topic here for this particular section is fundamental trigonometric identities. Now, this entire unit, Unit 7, is really going to be dealing with trigonometric formulas and solving trigonometric equations, and it all begins with these fundamental trigonometric identities. Okay, so there are several of them to look at here, and so they're grouped into 5 different categories. You've got your reciprocal identities, which you can all look at, and it kind of shows you what each one of the trigonometric functions is equal to as far as the reciprocal of one of the other trigonometric functions in terms of that. You've got 2 quotient identities for tangent and cotangent. You've got what are known as the Pythagorean identities here. You've got cofunction identities here, and then your even and odd identities. Okay, so we will take some time over the course of this unit to get familiar with all of these, and you learn how to utilize them to help us solve different types of problems as we move through this unit. Alright, so today though in this section, what are we going to be focused on? Alright, it's going to be focused on primarily using the given values, okay, to evaluate the other trigonometric identities. Alright, so using the identities to help you evaluate the rest of the trigonometric functions. So like for example, okay, if they give us the sine of x is equal to 1/2 and the cosine of x is equal to square root of 3 over 2, can we use that information along with the identities to be able to come up with the values of the other 4 trigonometric functions? Okay, so if they've given us sine and cosine, what's next? Tangent. We need to find the tangent of x. Alright, so in order to find the tangent of x, okay, we've been given 2 identity options here. Okay, we know that tangent is equal to 1 over cotangent, and we know that tangent is equal to sine over cosine. Okay, now here's the deal. We want to, the one that's going to be useful to us is going to be the one that we already have the information for. Well, they've given us sine and cosine, and so that's the identity that I need to use here. So tangent is equal to sine over cosine. Well, I know what sine and cosine are equal to, so tangent here is going to be equal to 1/2 divided by square root of 3 over 2. Alright, and it should make sense why that identity is true, because remember, the sine value is going to be the y coordinate in the equation, and then the cosine value, remember, is going to be your x coordinate of the point on the unit circle, right? And remember what tangent is, it's y over x. Okay, so if sine is equal to y and cosine is equal to x and tangent is equal to y over x, then it makes sense that tangent is equal to this identity, sine over cosine. And you can verify that on the calculator if you wanted to. Put in a value for the angle and see if tangent of that angle is equal to sine over the cosine of that angle, and you will see that it is. Okay, so how do we simplify this now out just like we normally would? Go ahead and divide by the reciprocal, so that will be, let's see, 1/2 times 2 over the square root of 3. My 2 is going to cancel. 1 over the square root of 3. Got to rationalize in the denominator. Square root of 3 over square root of 3. Let's see what happens here. So that's going to be square root of 3 over 3. And that is the value of tangent based on the values, the given values of sine and cosine. Okay, so we figured out tangent. What's next? Let's go secant. Alright, so we want to figure out what secant is equal to. Well, let's see what our identities tell us. Right here we've got secant is equal to 1 over cosine. Do we already know cosine? Yes, we do. It was given to us. So secant is going to be equal to 1 over cosine, which was square root of 3 over 2. All right, square root of 3 over 2. All right, that a little better. All right, so again, we'll multiply by the reciprocal of the denominator, which is going to be 2 over the square root of 3. And so when you multiply that out, 2 over the square root of 3. Again, we don't want square root of 3 in our denominator here. And so that will be 2 square roots of 3 over 3. So that'll be your value of secant. So what's next? Cosecant. So cosecant of x, let's see if we have an identity that tells us what that's equal to. Cosecant is equal to 1 over sine. So that's going to be 1 over 1/2. Which once again is going to be 1 over 1 times 2 over 1, which is equal to 2. So the cosecant of x is going to be equal to 2, and the last one is going to be the cotangent. Oops. Cotangent of x. Let's see what we got here. All right, so we've got two options also for cotangent. Okay, so we can go cosine over sine, which we have. But remember, we also figured out the value of tangent earlier, so you could actually use 1 over tangent as well. So either one of these two identities can be used as an option for figuring out the value of cotangent, since we already have tangent and we got sine and we got cosine. All right, let's go with cosine over sine. And so cosine, again, square root of 3 over 2 and divided by 1/2. So that'd be square root of 3 over 2 times 2 over 1. 2's will cancel out. That's going to be equal to the square root of 3. Probably could have done that maybe a little bit quicker by just taking the reciprocal of the tangent function there, if you wanted to do that. All right, and then simplify it back out. It would simplify it back out to the same thing. Okay, but in any case, that's what you've got. Okay, let's try another one with different values now. All right. So here I've got secant is equal to square root of 2, and sine of the angle is equal to negative square root of 2 over 2. Okay, so based on that, I need to see if I can find the other remaining 4 trig values. So let's see if we can find cosine of, they're using theta, so I guess I should stick with that. All right, so okay, so let's see if we can find an identity now with cosine in terms of either sine or cosecant. And so with cosine, we see that cosine is 1 over secant. And so since we have the value for secant, let's plug it in. It's going to be 1 over square root of 2. And so we can rationalize the denominator here, top and bottom by square root of 2. So it's going to be 2 square root of 2. Whoops. Square root of 2 over 2. And then so that's going to be cosine. See if we can find tangent of theta. And so again, we're looking for tangent. And remember, tangent is sine over cosine. Sine was given to us. We just found the value for cosine, so let's use that one. Tangent is sine over cosine, which is going to be negative square root of 2 over 2 divided by cosine, which we just found to be square root of 2 over 2. And so I can see pretty quickly that that's going to be negative 1. What else? Cosecant of the angle. Okay, so for cosecant, we know that cosecant is equal to 1 over sine. So that's going to be 1 over negative square root of 2 over 2. And so we will divide that out. 1 over 1. Ooh, I won't do there. 1 over 1 times negative 2 over the square root of 2. It's got to be the reciprocal of the denominator. That's going to yield me a negative number. And that's going to be negative 2 over square root of 2. And so again, I've got a denominator that I need to rationalize times the square root of 2 over 2. Still going to be a negative answer, and that's going to, now that's going to give me 2, which will cancel with this 2, which means my answer is going to be negative square root of 2. Alright, so there you go. Let's see, really just one more that we need to find, and that's going to be the cotangent of the angle. Okay, so let's take a look at cotangent. So for cotangent, we've already found tangent, so we could do 1 over tangent if we wanted to, or we could do cosine over sine. Could do either one of those two and get the same answer. Let's do cosine over sine. So cosine, square root of 2 over 2, and sine is negative square root of 2 over 2, and so that's negative 1. Alright, so there you go. So that is how you use these identities to take given values to find other trig values.